Namaskar, Jai Hind, Vande Mataram. This is Kunal Mehta from Make Me Scientific, and I'm going to take up various different problems from calorimeter topic. And I've seen that the students are struggling a lot in calorimetry chapter as well as the numericals related to calorimeter. See, after application of formula, it's not over. You need to lower down and narrow down on the mathematical skills also. So without wasting any times, let's discuss about the numericals of the calorimeter part, right? So here we are given a vessel which is made up of copper, and then yes, it contains 104 grams of water in it. So I'm just going to roughly draw a vessel, and this vessel is made up of copper. Usually all the calorimeters are made up of copper because their specific heat capacity is very less. Our aim is to study the heat transfer between the mixtures, the constituents inside the calorimeter. So we would be wanting that calorimeter should not take up larger amount of heat energy from the mixture itself, right? Okay, so this is the calorimeter vessel, and here we have 104 grams of water. And then the temperature of the calorimeter and the water is 30 degree. Even if it is not given in the question, you need to understand that the liquid and the calorimeter cannot be at different temperatures. So if you put a water inside, say for example, a copper vessel, then the temperature of the copper vessel and the water should be the same. So the calorimeter vessel also has temperature 30 degree Celsius. Mass of calorimeter is of course 42 grams, and the specific heat capacity and everything is given to you. Now we are adding a piece of ice into it. We don't know what is the mass of the ice, so let's call that as an M. Temperature is of the ice is not given. Oh yes, it's given, it is 0 degrees Celsius. Now it completely melts into water like this. And then this water, it also shows some increase in the temperature, and finally its temperature becomes 10 degree as per the question, because the final temperature of the mixture means the calorimeter. So I should say final temperature of calorimeter is also 10 degrees Celsius. Final temperature of the water is also 10 degrees Celsius, and the water and the ice which is melting into water at 0 degree, its temperature also is at 10 degrees Celsius. So in equilibrium, everything has to be at the same temperature, right? All right. Now, as per the principle of the calorimetry, heat lost is equal to heat gained. Now, who is losing the heat energy? Of course, the body at high temperature. And here there are two objects which are at high temperature, that is water as well as the calorimeter vessel. So I should be saying that the calorimeter and water, the 104 grams water. I will not be suggesting you to draw the diagrams and this much, but since this is first time I'm explaining this in great details, so that's why I'm explaining with the help of diagram and the other steps. Otherwise, you may directly proceed with the this particular step, that is according to the principle of calorimetry, heat lost is equal to heat gain, and you may start solving the problem. Now, who is losing the heat energy? So we have already discussed the calorimeter, whose mass is 42 grams, and the water, which are at 30 degrees Celsius both. But who is gaining the heat energy? Definitely ice, and ice is completely melting into water. So ice, when the ice melts into water, that water, its temperature rises from 0 degrees Celsius to 10 degrees Celsius. And we don't know the mass of the ice. The same is the mass of the water. Because suppose you have 5 grams of ice, that would be melting into 5 grams of water, and that 5 grams of water will show the rise in the temperature. We know the formula mc delta T and ml. Wherever you have change in temperature, we have to use mc delta T. Wherever you have state change, we have to use ml. So over here, the calorimeter vessel, right, its temperature is changing from 30 to 10. So temperature is changing. So mc delta T of calorimeter. Again, water from 30 to 10 of the water. Here ice is melting. So ml plus the same m gram mass of water shows rise in temperature from 0 to 10 degrees, right? Now, let us solve this. Let us plug in the values and solve the equation, right? So we have mass of the vessel as 42 grams, and let me check, the specific heat capacities are given in grams, so we need not to worry. So this is 0.4, right? This is gram joule per gram per degree Celsius. You need not to write down the unit as well. This is just first time. And the change in temperature is always positive. Always remember, higher temperature minus lower temperature. So it is 30 minus 10. Otherwise, you will end up into the negative things and you will make a mistake over here. So from 30 to 10. This is 104 grams of water, and then 4.2, again 30 minus 10. We don't know m, but 336 is given. From 0 to 10, so that is 10. So 0 degree Celsius water to 10 degrees, so 10 minus 0, that is like that, right? Now see, the gram is going to get cancelled, right? A degree Celsius from here, degree Celsius from here will get cancelled, so everything is in joules, right? This is 42 into 0.4 into 20 plus 104 multiplied by 4.2 into 20 again is equal to 336 m plus m into this decimal goes off with the 10, so it becomes 42, correct? So now from here this decimal and this cancels off, so 42 into 4 into 2 plus 104 into this decimal goes off with 4.2, so that is 4.42 into 2. That is equal to m stands common, so 336 plus 42 is equal to 378, right? So now 42 times 2, I am going to pull it out as common, so that is 84. Now from here 4 plus 104 is equal to 378 times m. So now let's solve this one. So the m value is equal to 108 times 84 divided by 378. Now I would suggest the students to cancel off these with the help of 2, right? So this is, let me try it with 3 also. 8, 7, 3, 10, 18. Yes, it definitely goes with 3. 3 ones are, 3 twos are, 3 6 are, and this again goes off with 3 twos are 6 and 3 eights are 24. Now I would be again checking 6 plus 2 8 plus 1 9 again, so 3 fours are 12, 3 twos are, then again 3 threes are 9, 3 6 are 18. So now I am getting 36 into 28 times 42. So again I would be cancelling with this 3 14s are, then 3 12s are, then again this would be 7 2s are 14, 7 4s are 28. So this is 12 4s are 4, 2 1s are 2, 12 4s are 12 2s are 24 grams. So final answer is 24 grams. Now since everything was in SI unit except the grams, so the final answer is 24 grams. This is the answer to the problem. Let's go ahead. We have 100 grams of calorimeter vessel which contains 150 grams of water. 50 degrees Celsius is the temperature. So, but obviously 50 degree has to be the temperature of the calorimeter as well. We are adding ice into it. Okay, so we are adding ice into it. The mass of the ice we don't know, but finally the temperature of the mixture becomes 5 degrees Celsius. So since the temperature of ice is not given, so I'll take 0 degrees Celsius, correct? Now what happens is these two are going to lose heat energy. And then as a result, the ice will change into water at 0 degrees Celsius, and that 0 degree water's temperature will also increase to 5 degrees Celsius. So we'll start as usual with heat lost is equal to heat gained. So here two substances are losing heat energy, the calorimeter and the vessel, and the ice is converting into water, and then that water its temperature goes up from 0 degree to 5 degree because it's given in the question. So it is to be understood that the complete ice melts and then the temperature would go to 5 degree. So heat lost, we will be having two terms, and of course both will be mc delta T, because the temperature of the calorimeter and water decreases from 50 to 5 degrees Celsius. So this is a vessel, this is mc delta T of the water, that is the entire ice changes to water, so that is ml, we don't know the mass, right, of the ice, and that m grams of water which is formed, its temperature increases, so mc delta T of the water. Now let us substitute the value. This is 100 grams into calorimeters, yeah, it is 0.4, and delta T is from 50 to 5. So as I said, you have to take higher temperature minus lower, so it is 45 plus again 150, 4.2 into again 45, m times 336. Be careful, they sometimes might give you 330 also. M into 4.2 into from 0 to 5, so it is 5 minus 0. 1 0 goes off, so it is 40 into 45 plus 1 0 goes off, so 15 into 42 into 45. Now m common, so here it is 336 plus 21, so I should be saying this as 351 because this is 21, right? 4.2 into 5 is 21 and 21 plus 336 is 351. So I can very well pull out common from here as 45. So this is 40 into 45 plus 15. I want to just write this as 14 threes are, and again 45. You can simply go by your own instincts, right? That is up to you. So 45 is common from here. So this is 40 left, plus again this is 45 being pulled outside. So again 45, 145 left into 14. That is m into 351. So now m is equal to 45. Then I would be saying 40 plus 45 times 14 divided by 351. Now I can narrow down to like say 15. I can cut off this by 5. 3 ones are 3, and then 3 5s are 15. 3 ones are 3. 3 ones are 3, and then 117. So now I leave this part on you, right? I have already given you the idea. You can use these steps, and finally you will get the answer in grams as 84.4 roughly. So this is how you should be going ahead. I would suggest that we go for the fourth question because third is a lot more typical, right? So we'll solve 4, 5, and then we will go to the third one. So here we have a calorimeter vessel whose mass is 46.5 grams. Then it contains 80 grams of water at 23 degree Celsius, which means the calorimeter vessel is also at 23 degree Celsius. And then we are adding 60 grams of sand in it, and its temperature is 90 degree Celsius. Correct? And then the final temperature of the mixture is 30 degree. Now, how come it is possible? Because now this is hot substance and these two are comparatively cold. So now the heat transfer actually takes place from sand into the vessel and the water. So what is going to happen? The temperature of the sand is going to decrease and the temperature of water and the calorimeter is going to increase, and the final temperature is recorded as 30. So finally this goes to 30 degree, its temperature increases to 30 degree, and then its temperature decreases to 30 degree. So this is heat lost, of course, and this is heat gained, and this is also heat gain. So when you write heat lost is equal to heat gained, please understand that there is only one term which is going to be heat loss, and there will be two terms in heat gained. Why it is so? Because there is only one substance, sand, that is going to lose heat energy, and due to that temperature decreases, so MC delta T of the sand, that is equal to MC delta T of the vessel plus MC delta T of the water. Correct? So let us substitute the value. 90 grams into specific heat capacity of the sand is given to us as, okay, that is what we need to find out, right? So we need to find out that. So I'm going to take this as C itself, and then from 90 to 30, so it is 60. Higher temperature minus the lower one. Then again, here mass of the water, okay, vessel, so it is 46.5 times specific heat capacity of the vessel is already given to us 0.4, and delta T is from 23 to 30, so it is 7. Plus again mass of the water, that is 80 grams into 4.2 into high temperature minus low, so again it has to be 7, right? So now let us solve this one. So 90 into 60 into C, that is equal to, this can be written as 465 by 10 multiplied by 4 by 10 multiplied by 7, and this can be written as plus 80 into 42 by 10 times 7. Okay, so now this becomes a pretty easier problem. So now 6 nines are 54, so 5400 into C is equal to this number, right? This multiplication plus this multiplication. Now this is in multiplication, that would go down in division, so you would be getting the specific heat capacity of the sand, but it would be in joule per gram per degree Celsius, because everything over here we have taken in grams, right? And so if you solve this, you will get your answer as 0.68 joule per gram per degree Celsius. I'm leaving this calculation on you part. I think that this multiplication part you will be able to do it very well. Okay, now if what else is being asked to us, so we actually solved D part. Now heat absorbed by the calorimeter vessel, so that is equal to MC delta T. So once you have found the value of C, you plug in over here, right? Oh, sorry, I'm sorry, this is MC delta T of the vessel. So simply this multiplication in joules would be the answer to the A part. So this multiplication is the answer to the A part, and this is the heat absorbed by the water. So this multiplication is the answer in joules to B part of your problem. Now heat released by the sand is equal to 5400 into 0.68. So this answer in joules will be the answer to your C part. Correct? Now let's discuss problem number 5. So it says that we have 250 grams of water at 30 degrees Celsius. And then it is already there in a copper vessel whose mass is 50 grams. So by default, the copper vessel also has the same temperature, that is 30 degrees Celsius. Now what we are doing, we are adding the ice into it, and the temperature of ice is not given, so we will consider the temperature of ice to be 0 degrees Celsius, and we are adding m grams of ice into it. Now the entire mixture, it is given in the question that after mixing these three, or after mixing the ice into the water which is already there in the calorimeter vessel, the temperature of all the constituents in thermal equilibrium becomes 5 degree. That means the water and the vessel which are at higher temperature are going to lose its heat energy, and its temperature is going to decrease till 5 degree. By that amount of heat, the same amount of heat will be absorbed by the ice. The complete ice is going to melt, and that ice will turn into 0 degree water, and that 0 degree water, its temperature will also rise to 5 degrees Celsius. Correct? So I should be better writing here as heat lost, that is equal to heat gained. But who is losing the the heat energy, water, and its temperature goes down to 5 degrees. So I should be writing mc delta T of water plus mc delta T of the vessel. That is equal to the entire ice is melting, ml, plus the same amount of the ice, which is now water, the same mass. Its temperature goes from 0 degree to 5 degrees Celsius, that amount of water. So mc delta T of the water. So I should be plugging in all the values. So that is 250 into, that is 4.2 joule per gram per degree Celsius times delta T, that is from 30 to 5 degrees Celsius. So the difference is going to be 25. That is equal to, okay, now plus the mass of the calorimeter vessel is 50 into C of the vessel is 0.4, because this is given in kg and the mass over here is given in grams, 50 grams. So be careful that either you convert the kilogram, I mean the grams to kilogram, or you convert this specific heat capacity, which is in joule per kg degree Celsius, into joule per gram per degree Celsius by dividing that into 1000. Again, its temperature from 30 to 5. The entire ice, whose mass is m, melts, and specific latent heat is given as 336, because we are considering everything in grams, right? Plus the same mass of water which is formed, and 4.2, its temperature rises from 0 to 5, so difference 5 minus 0. Okay, so this is 250 into 4.2 into 25 plus 50 into 0.4 times 25, that is equal to m into 336 plus 5 times 4.2 is 21 times m. So if I pull out m common, then this is equal to 357. So now this is 250 times, or 25 times 42 times 25 again, plus again 5 times 4 times 25, removing the decimal with the 0. So I can very well pull out 25 common. So inside it remains 25 multiplied by 42 plus 5 fours are 20. That is equal to m, and this entire part divided by 357. If you will calculate this, you will get your answer as 74.9 grams, which is the answer to the problem. So I'm leaving this calculation, this last part, on you. I think you will be very well able to do that. Okay, so now let's see another problem. Here it is being said to find out the latent heat of fusion of ice, and we have a calorimeter whose mass is given. So the calorimeter mass is given as 5 grams, and it contains 50 grams of water. And the temperature of both of them initially were 30 degrees Celsius. Now we are going to add some quantity of ice into it, that is 5 grams, and it is at 0 degrees Celsius. Now it is being said that the final temperature of the mixture is 20 degrees Celsius, which is clearly abundant from here that this entire ice is going to melt into 0 degree water, and that water, its temperature will rise from 0 degree to 20 degrees Celsius. And now since these two are at higher temperature, so they both are going to lose the heat energy to the body at lower temperature. So heat lost will be by two of them, and heat gained will be, again there will be two terms. One, the ice completely converting into water, and that water, its temperature is again increasing. And we know that since two things are losing heat energy, due to which the temperature decreases from 30 to 20 degrees Celsius, which means mc delta T for the vessel and mc delta T for the water. Now the entire ice melts, so ml for the ice, and that ice now it is in form of water, and we know its mass 5 grams. So 5 grams ice converting into 5 grams of water at 0 degree, now its temperature also increases, right? So mc delta T, please understand one thing, this C is the specific heat capacity of the substance whose temperature is changing, which is water. It's not ice, correct? So let us substitute the value over here. That is 5 grams into specific heat capacity. It is given as 0.4 over here. So I'm going to substitute the value 0.4 from 30 to 20. Always remember high temperature minus low temperature. In this equation, as per the heat lost is equal to heat gained, everything should be positive, delta T. Right? Delta T has to be positive, Q has to be positive. Plus MC delta T of the water, so 50 grams into 4.2, again from 30 to 20. This is the heat lost. Now the heat gain will be 5 grams into the latent heat, plus here the mass is 5 grams, which is converting into water, into 4.2 into from 0 to 20. So the difference is 20 minus 0. So now let us again write this and solve this one. So we have here 5 4s are 20. So it is basically 2 into, we have 30 minus 20. So 10 plus, again it will be 5 into 42. So this makes 5 zeros as 5 2s are 10. So 0, 1, 5 4s are, so it will be 242 times 5. Yes, that is 210 times 10 again. That is equal to 5 times L plus 21 times 20. Correct? So now let us again, sorry. So now let us solve this one. So this is 2 into 10, so that is 20 plus 2100, that is equal to 5L plus this is 420. So basically this is 2120 minus 420, that is equal to 5L. So now 2120 minus 420, that is 1700. So L is equal to 1700, that is joule, and now this 5 is basically in gram, so divided by 5. So this is 5 ones are 5 3s are 15, then 2, so 5 4s are, and this is roughly 340 joules per gram. That is the latent heat of fusion for the ice. Now what else is being asked? So we have found out the D part, calculate the latent heat of fusion of the ice. Now the total heat gained by the ice. So I believe that the total heat gained by the ice, that is equal to 5 times L, right? So that will be equal to 5 times L. So it is 5 into 340 joules per gram. So as per me, what I suggest is 1700 joules should be the answer to the problem. And then we have what quantities of heat are released by the water. So the amount of heat released by the vessel is 20, because it is pretty much clear, 5 into MC delta T. So that is 20. And then heat lost by the water, that is 2100, and the total heat lost will be equal to 2120, as I have already mentioned over here. So that is this is the B part. And what is the total quantity of water in a calorimeter? That is very easy, because already there was 50 grams of water. Now the 5 grams of ice is melting into 5 grams of water, so total 55 grams is the answer, right? If you feel I have made any mistake in C part, please do comment in the comment section. Now let's move on to problem number 7. We have a brass whose mass is 200 grams and at 100 degree Celsius. Now it is placed in turpentine oil and a copper vessel. Now the mass of the calorimeter vessel or the copper vessel is 50 grams. It is at 15 degrees Celsius. The same turpentine oil is 400 grams mass, and it is also at 15 degrees Celsius. Now you can very well see that when the brass ball is placed inside the turpentine oil, this is hot and these two are cold. So the heat energy will be lost by the brass and it will be gained by the vessel and the turpentine oil. So if I write heat lost, that is equal to heat gained, then in heat lost there will be only one term. And why it is like that? because there is only one substance, brass, that is going to lose the heat energy, and due to which its temperature falls down to 25, because it is being said final mixture is at 25 degrees Celsius. So copper, which was at 15 degree, its temperature will go up to 25. Turpentine oil's temperature is going to go up to 25, and the brass is going to lose heat energy, and its temperature is going to reduce from 100 to 25. So here brass MC delta T, then turpentine oil's temperature goes up, so again MC delta T of the turpentine oil plus MC delta T, because two things are going to absorb the heat energy, so heat gain will have two terms. Again, this is of the copper vessel, correct? So now let us substitute the value. M is the mass of the brass, so that is 200. Now we are supposed to find out the specific heat capacity of the turpentine oil. Okay, heat lost by the brass. So fine, we have been given that specific heat capacity is 300, but that is joule per kg. So here we have grams, so this is 0.37. Please understand that, or else you will have to convert 200 grams into kilogram, or this is 370 joules for 1 kg. So for 1 gram it will be 0.37, right, times delta T, that is from 100 to 25. Now that is equal to mass of the copper vessel. Okay, this is for turpentine oil, so it is 400 into, we don't know the C for turpentine, but delta T is again from 25 and 15 difference, high temperature minus the low temperature. Then the mass of the copper vessel is 50 into C of the copper vessel is 0.4. Yes, because that is 400 joule per kg, right? And then we have delta T, so that is from 25 to 15 again. Now see, if you calculate this one, 200 into 0.37 into 75, correct, that is equal to 400 into C into, this is 10 plus 50 into 0.4 into again 25 to 15, so this is again 10. Right. Now what are the things which are being asked to us? Heat lost by the brass. So this multiplication, this product in joules will be the answer to our first problem, that is heat lost by brass. So if I multiply this one, I will be getting this as 200 into, so 200 into 75 into 0.37, that is 5550 joules. That is the answer to our problem. So this is 5550 joules. Now the heat energy gained by the turpentine, right? So that is this one. Now some of the students say, sir, we are not given C, correct? Then we do know that that is equal to 4000 into C, sorry, 4000 into C, yeah, plus this is 50 into 4, so 0.4, so that is 2, and this will be 20. So this 20 goes on that side, and we will be having 5550 minus 20, that is equal to 4000 into C, correct? So this is 5530 joules, that is equal to 4000 C. Now this 4000 C itself is equal to heat gained by turpentine oil, which is equal to 5530. So that is the answer to the problem, 5530 joules. I have seen many students who are arguing that, sir, we are not given C for the turpentine, how should we find out? But suppose I have 100 rupees, right, and I have given you 20 rupees. So how much of money do I have with me still? That is 100 minus 20. So total 5550 joules is heat lost. And then the heat gained by the copper vessel is 20. So the leftover 5530 goes to the turpentine oil. So that is the direct answer. Right. From here you can also find the specific heat capacity by simply dividing 5530, and that is 5530 divided by 4000, that is 1.382. So the specific heat capacity is 1.382 joule per gram per degree Celsius, because now everything is in grams, so we would be getting that answer. So we have simultaneously solved A, B, E and actually D also. The total heat energy gained is same as 5550, and out of that 20 joules is being only absorbed by the calorimeter. That's why we prefer copper as a material for calorimeter, because we want the total heat exchange to be between the constituents, and the vessel should not take up anything from it, or even if it takes very little bit amount of it. So it is very much evident from here that why copper is being used, right? So now let's discuss problem 3. Actually, I had kept this problem at the last because of a specific reason. And the reason is because this problem is a bit difficult, right? And the calculations are lengthy, otherwise it's okay. So now let's discuss this one. So we have calorimeter of mass 60 grams, and in it we have water 180 grams, and the temperature of the vessel as well as the water is 29 degrees Celsius. When you add ice to it, the temperature of the ice is minus 10 degrees Celsius this time, and its mass is 37.2 grams, which is already given in the problem. And the other data are also given. So now what can happen is, first of all, the heat will be lost by two objects. One is calorimeter, another is the water. Now that heat energy will be absorbed by the ice. Now, first of all, the ice is going to increase its temperature from minus 10 degree to 0 degree Celsius. Then the ice is going to melt into water. And then the temperature of the water may rise to some temperature. But we don't know what's the final temperature. What is going to happen, we don't know at all. So we are going to use trial and error method. First of all, we have to analyze what is the maximum amount of heat lost. Now, if you even take a very big piece of ice and put it over a very small drop of water, it's not possible that the water drop is going to freeze into ice. Why? Logical reason. Suppose temperature of the water droplet is 27 degrees Celsius and the temperature of the ice is 0 degrees Celsius. Then the temperature of the water drop is going to decrease to 0 degree, and then the equilibrium has established. Meanwhile, very small section of the ice might have started melting from the top or the bottom. But when the equilibrium is reached, the temperature is 0 degree, it can have a mixture of two states, correct? So now, what is going to happen? The calorimeter can maximum come to 0 degree, even the water can come maximum to 0 degree. So heat lost will be equal to mc delta T, because we use formula mc delta T for change in temperature. So mc delta T for the vessel plus mc delta T for the water till 0 degree. This is just an estimate, right? So the mass is 60 into 29 minus 0. From 29 to 0 we are assuming. So 29 into 0.4 plus 180 grams of water, 4.2 into from 29 to 0. This is 29. So when you calculate this 60 into 29, yes, you will get the value as 696. And I have already calculated this one, and this is somewhere around 21924. Correct? So if you add these two, you will get your answer as 22620 joules, which means this is the maximum heat that can be lost by both of them. Now let us see what will happen over here. The ice, first of all, its temperature is going to come from minus 10 to 0. So here this is mc delta T of ice. Then the ice, complete ice, is going to melt into water. So again it is ml. But please ensure that this C is the specific heat capacity of ice, not of water. In the expression mc delta T, C is the specific heat capacity of the substance whose temperature is changing. So this is M, which is 37.2, specific heat 2.1, because this is in joule per kg. So joule per gram would be this one, and delta T is from minus 10 to 0. So 0 minus minus 10, difference in temperature has to be positive. So 10 plus 37.2 into 336. So now if you calculate this one, no, you will get this answer as somewhere around 12499. So I have approximately taken this as 12,500 plus this as 781.2. which adds up to 13281 joules. So now maximum heat loss is way larger than the amount of heat required for the ice to reach from -10 to completely melt it to 0 degree water. So that means still there is some amount of heat energy left, which will be again taken up by the water from 0 degree Celsius, and it will reach to some temperature T. So now let me tell you one thing, that the final temperature, this is calorimeter and water, and here you are adding ice at -10 degrees Celsius. So what is going to happen? Please understand this. 29 degrees Celsius, 29 degrees Celsius. This may reach to some temperature T, this may reach to some temperature T, and this ice will reach to 0 degree Celsius. Then it is going to completely melt into water at 0 degree, and again it is going to reach at some temperature T. So the final temperature of the mixture is going to remain T, not 0, right? This was just an estimate that we had used for the calculations. So now let us use the formula. So MC delta T for calorimeter, that is the vessel, MC delta T for the water, that is equal to the ice, MC delta T, because it is going to reach from -10 to 0, then the ice is going to melt, and then the water which is formed, its temperature is going to rise to some temperature T, correct? From, this is of water, from 0 to T. So now very carefully substituting the value, this is 60 into 0.4, that is the specific heat capacity of the vessel, and this is from 29 to T, plus this is 180 into 4.2 into 29 minus T, because the water reaches again from 29 to T. M is the mass of ice, so 37.2 into specific heat capacity of the ice, not of water, so that is 2.1 into, this is from -10 to 0, so the difference is 10. The complete ice is melting, so 37.2 into 336, and plus this MC delta T, that is again 37.2 grams of water. Its temperature rises from 0 to T. So now this calculation, I think I should leave it on you part. If you calculate this, roughly the temperature, you are going to get this as 10 degrees Celsius. That is the answer to the problem. You may get this answer as 10 point something also. You just have to solve this particular equation. Please be very patient in solving. I hope this video was helpful. If you have any doubts, please do comment in the comment section. Thank you.